Shall we start now? Am I audible?
Yes.
Thanks. So let me start with the discussion today because we don't have much time. We have to cover in 30 minutes only. And today I'm going to talk about the pseudonymization, right? So, and already you might be knowing the agenda for the today's discussion. We are going to cover this intro, then pseudonymization techniques, and then implementation part, and finally the demo. So in the intro, we'll cover the difference between the pseudonymization and the anonymization, and then we will cover the few different techniques that can be used to pseudonymize the data. And then we'll discuss about the POCs of those techniques. And finally, we'll see a small demo on how to use the PG crypto function for the pseudonymization. So let me first give you background of this masking solution. So we were working for one of our customer Genpact. So they want to move their data from the on-premise to the cloud, and there was a requirement from the security teams and for the security regulations to anonymize the data before moving to the cloud, right? So that's why we come up with this solution so that it can help any of the customers who are trying to build in-house solution rather than going with the solutions which are in the AWS marketplace or available outside the open source. So let me start with the pseudonymization definition first. I will just try to explain in the diagram. Okay, so let me just sketch pad. So take a case of the example, right, where we have our database in the hospital, okay, and we want to migrate this data to the cloud. So there could be two categories of data. One of the category will be your PII data, that is a personal identifiable information, and the second category we will have the non-PII data. That is not personal identifiable information. So from the name itself, we can see, right, the PII data means the data from which we can identify an individual, right? So suppose if any of the columns in the data contains the name, age, email ID, sex of any person, then that is categorized in the PII data. So there could be different tables which belongs to this PII category. And there could be some other tables like information about the hospital, information about the insurance companies, information about the cities, metadata tables and other tables where we don't have the personal data of the patients, right? They will be classified as non-PII. So in the PII itself, there could be your master data will be there where you have information about the patients, like the patient name, patient age, patient email ID, all those primary details, and other could be like visit details could be there, other could be the disease details, like that will be linked to your master table using the patient ID, right? So this is how generally the structure is there in different organization. I'm giving this example of hospital, but this is valid for the other domains as well. Now suppose if I have to migrate this data to the cloud, then this data can directly go to the cloud and we can move this table as it is. But for PII data, there are some regulations that needs to be followed. So we have to anonymize those columns which are identified as PII, right? So first we have to run one job here and convert those PII tables into this anonymized PII. Okay. And now they are ready to move to the cloud, right? What I mean by anonymized PII table means suppose if your name is John here, we'll convert it to the Sam. If your age is 42 here, it will convert it to 23. So we are just converting the primary information of the patients in this table using this job, okay? And then we are moving this table to the cloud so that if someone is running the analytics on it, cannot identify the actual person name. He will get only the fictitious name, fictitious age of the person which we have converted over here, right? So this process is called as the anonymization. So this is the most common word which we heard on day-to-day basis. Sorry, my writing is not that much good. So this is called as anonymization, right? Now comes the second case where I want to run some analytics on my data on the cloud, where I want to identify, which of the patients visited, uh, most yesterday to this hospital. So to get to know that data, I have to get to know the actual patient information, right? So that I can inform the patient that you have, visited most of the time yesterday and today you're not coming. Because are you ill or you are not well, for such kind of use cases. So what I will do is I will try to identify that actual data. So this use case this anonymization job will not work for me. So I can create one mapping table either on the source or on the target to store the original PII data and the anonymized value of the PII for all those columns, right, which I am transferring it to the target. And once I have created this mapping tables, then I will use this animation job to first load the mapping table, and then from the mapping table I will be loading the anonymized value of those data to the cloud. So again, suppose in case if I want to know that what is the actual name of the person which is referred as a John in the cloud, then I can just query my mapping table to identify what is the actual name of the person, where name is equal to John, and it will give me his name was Sam or whatever the real name of the person in the database, right? So this is called as pseudonymization because we are able to identify the actual data. Okay, so hope it is clear now. So this is the same mentioned here, right? That we can de-identify the original data and it is used mostly for the analytical purpose. So these are the two important points that differentiate the pseudonymization from the anonymization. Okay. So again, there are different techniques, like we can use mapping table as we discussed now. We can use the data encryption. We can use the data hashing. We can use the masking, right? So mapping table we already discussed. We are going to store the actual value and the fictitious value together in the table, either on the source or on the target, right? Encryption is something that we are going to convert the clear text into the ciphertext, right, using a key. So again, one of the advantage of encryption is that if you can encrypt the data, then you can decrypt the data as well, and you can identify the actual data using the same key, which is used to encrypt it, right? So this is what encryption is all about. And then we have hashing. So hashing is something that is only, suppose if you want to identify whether the document is valid or not, whether the password is correct or not, then what we will do is we will store the hash value of those passwords or those documents into the database, and during the authentication we'll check whether the new hash value is matching that hash value or not, right? So this is something what we do in the case of the hashing. So this is used for the validation and verification purpose. And masking is like very generic term which we can use for the complete mapping table, encryption, hashing, but there are some masking functions also available in the database, like we have our dynamic masking, static masking, that can be used to mask the data using the inbuilt function of the database, right? So this is are the high level techniques and for pseudonymization. Any questions till now? I think this topic is might be new to most of us because we are generally working in the databases and technical things. But this is very common, ongoing problem for most of the customers, right? And understanding this term will, help us to get to know the actual problem and maybe identify the right solution. So suppose in this scenario, right, we are having the PII and the non-PII data into the source side, right? And we are going to create a job at the source database itself. So this is called as a masking at the source, right? So we are converting it like what we discussed here. We will create an anonymized PII table and then we will migrate it using DMS or glue to the target database. So this is called as the animation in the source, and same thing can be done at the target also when we are just copying this PII table as it is to the target. This is also PII, and after that we will run the animation job to convert this PII to the anonymized PII, right? So this is called as pseudonymization at the target. And then other we have is during the migration itself, like using ETL job or using any DMS service, we can write some transformation rules, and there we can specify to use some SQLite functions to convert those input data into the target data, encrypt it, right? So these are the three different ways that we can do it. And let's discuss the pros and cons of all these three. So if you are doing at the source, so this is considered to be most secured one, right? Because before landing your data to the cloud, it is already anonymized. If we are doing at the target, then again, it will stay into the cloud till we run the job to anonymize the data. So that's why it is the least secured approach. And then at the transit, right? So transit is something, this is also secured because again, here also we are trying to anonymize the data before moving to the cloud. Okay, so let me just go to the next slide.
Yeah, Abhishek, just a quick question on this. So while we are doing the anonymization in transit, right? So in such a case, there has to be a mechanism present on the target, right? To again read the data like a mapping or something, correct? Or
Correct. Yeah. So if we are doing this in the transit, then we have to create one more mapping table where we have to store the encrypted values or whatever the
Mhm.
value we are masking it, so that we can trace it back using the same table. Yeah, you are right. And that table
Okay,
will, yeah, outside the database. Yeah.
yeah, fair enough. Yeah.
Now, these are the different methods which I explored, and maybe some other methods also, but I just want to focus today's session on these methods because I have used it and I had got something to show it to you. So first is the trigger and the key, right? So in this case, we are trying to create a trigger on all the PII tables, right? So that before getting loaded into the target, data will be encrypted, right? So this trigger will be before insert trigger and before update trigger on the PII tables on the target side, right? So whenever you are inserting the data or updating the data into the PII tables, this trigger will be fired and your original value will be replaced by the fake values or fictitious values. This is the first thing. And this approach could be sometime cumbersome because when you are running it, then every time you are inserting the data, it will encrypt the data, and it is going to cause a lot of CPU bottlenecks on the database. So this is not recommended approach when you have got a bulk data. If you're trying to move 1 lakh rows in few minutes or something like that, then this will cause so much of overhead on the target database. So this is not a very recommended approach. In that case, we can go with second options, which is we are running the anonymization job and the encryption key. So we will run this job scheduled wise like every half an hour on those PIA tables, and will create the anonymized values for the different PII data, and those data will be again transferred to the tables which are being consumed by the users. So we'll just look into the diagram later on, then you can correlate it better. So just try to understand that here we are just not directly copying the data into the target tables, rather we are copying it into the some staging table, then running the job, converting it to the anonymized value, and then putting it into the users to consume the data. Okay. And here we can create the job that is not residing in the database itself. We can create a Lambda job, or we can create a job in some other EC2 instance, which holds the actual key information, right? So key information is not be accessible with admins. But in the first case, when we are using the trigger and the key, here we have to put that logic of the encryption in the trigger itself, right? So if admin has access to the trigger, then he will come to know that which key are using, right? So that is one of the risks that can be identified here, that we can again mitigate by using a lambda function. If we are calling a lambda function from this trigger and putting the key over there, then we can bypass those admin access to the key. Now this is with the job and the mapping table that we already discussed now. So this is suitable when suppose because this will cause a lot of impact on the source and the target database when it is trying to select the data from the source and insert into the mapping table with the job, then it has to do the join on the source table, right? And again, while putting the data into the target, it is to join, because we want to only copy the incremental data, not the complete data every time, right? So this will be put some burden on the source and the target. But again, if you want to have some customized algorithm, or you want to use it like you want to replace name with name only, you don't want to use encryption values, then you can write your own function, and you can use this mapping table option. Other options are like third-party rule. There are different third-party rule like Delphix is there, and we have Data Sunrise that will give you the complete end-to-end solution of anonymization. So right from the data discovery to the data algorithm selection, like which kind of algorithm you want, to the centralizing the anonymization solution. So suppose if you are having the multiple databases on the target, which is Redshift, RDS, S3, lot of storages are there, and they are going to refer to the same table, right? In that case, you can refer to the third party tools as well, because they can provide you the centralized engine for masking across the enterprise. So we haven't explored the third party, we haven't used it here because it involves licensing cost. So I'm going to cover this first three techniques. Again, coming to the PG crypto, right? PG crypto is the extension in the Postgres that you can install it, and this is there is no cost involved here. You can just create the extension, and after creating it, there are other functionalities like you can do encryption, you can generate random number, you can generate a hashing function. But for our use case, we use encryption. So we have two ways to encrypt the data. One is symmetric and asymmetric. So these are the functions which can be used to do the symmetric encryption and asymmetric encryption. And here I'm just passing my original name of the person, and I'm using the key, right? And this function will return the ciphertext value of this name. Again, I can decrypt it by passing the ciphertext here, and it will give me the original name, right? This function. So this is a decryption function. But you have to make sure when you are encrypting and decrypting, you are using the same key. Otherwise, it will give you the keys corrupted, and it will not work, right? That is what. Okay. Now for the asymmetric encryption, I think we all are already familiar that we are going to use different keys for the encrypting and decrypting it. So here you have to create the key first, and then you will store the key into the database table. And once it is stored in the table, then you will refer this to encrypt the data, you will refer to the public key from the database table, and to decrypt the data, you will refer to the private key from the database table, right? But this is not a very good method because we are using the keys into the table, so that is also a very much secured method to use. So I would say, I have tested also, so better to use the symmetric encryption for such use cases. And this is a link where you can get more information about the PG crypto, what are the different functionalities that can be used, and other like hash function and random number generator, right? And different algorithms that can be used for hashing and encryption. Any questions, Stella?
Hi, Abhishek. This is Subhani.
Yeah, please.
Yeah, about the encryption and decryption, say the data is already encrypted, and the moment we decrypt, we identified the decryption, we lost the key, and the table is also crashed. So we don't have any information about the decryption. So in that case, how we need to proceed?
Yeah, in this case, if you don't have the key, then you will be not be able to decrypt the data. So that is a risk involved. So you can save the key in using secret manager, and you can store it somewhere to make it more sustainable, right? Otherwise, this approach is if you lost the key, and if you don't know the key, and if you have only the the ciphertext value, then from there you cannot track back, because if you can track back, then again it will expose your data, right? Any hacker can come and get to know the actual data. So main purpose of encryption decryption is the key which is there, and that is the important factor. So we should not lose the key. So as far as I know, maybe there could be, you can explore if there are any certain situations I have not faced across till now.
Okay.
But if there are something, then you can explore. Yeah.
Yeah, my next question was, do you faced any issues and how you fixed it? But yeah, luckily that was a good idea. No problem. Thanks.
Thanks for the question. Yeah, that is really yeah. Even I will also explore it, that what can be done, because this is something important point that we have to take care. But suppose if you're using the mapping table for storing those keys, then you can take the backup of the mapping table. But in this case, I would suggest to store the key in some secured format, like secret manager or any other, like system parameter store, where you can refer it whenever it's needed. Okay. So now coming to the architecture, right? So this is the encryption key and the job. So you can see here, right? We have two categories of data. One is the non-PII that directly flows to the database, and other is the PII that has to go to the PII tables first. Then job will run and it will encrypt it, and then it is going to send the encrypted values to the target table, and user will consume this table here, right? And again, to decrypt it, you have to run the PG symmetric decrypt function to get that actual name of the user. So this is the command which is used to install the PG crypto extension. And after installing it, I just inserted one sample rows into it, like name and age. And once I have inserted it, then I have used the functions to encrypt the data before storing it. And now the data which is stored in the database is the encrypted format, right? Now I will select the data based on the value of this name. Then I will get the actual name which I've used to encrypt the data. So this is how the symmetric key encryption works in the case of the using the PG crypto. Okay. So I mean, nothing very new here, but again, these are the different use cases that we have to understand. In which case we have to use trigger, in which case we have to use the job, and all these things. So this is the second scenario. Here we are going to use the trigger, right? So we have got requirement from the customer security team that they don't want to store the data into the database, PIE data into the database, right? So for that, if we use this approach, here you can see we are storing the PIE data for here, and then we are again running the job and converting it into the anonymized value, right? So this is being stored. So this is not very secured way. To come up with solution, we created one trigger on the tables, so that before insert and before update trigger, so that it is going to before inserting the data into the target, it will encrypt it, right, using this trigger. So this is the main definition of the trigger. So you can see here it is going to just convert the name and the age, right, whenever we are trying to call this function, and this trigger is calling this function, right? So here this trigger will be called whenever you are inserting and updating data on this masked table, right? So this is also one of the way that we can do the encryption. But here problem is, if you are a DB admin, then definitely you will access to the code of the trigger, and you can see that what are the keys being used. So just to mitigate it, as said earlier, you can create a lambda function and you can call the lambda function from this trigger, right? So after creating this trigger and this function, I just try to insert the data into this anonymized table, and you can see here after inserting the data, what I see is this is the ciphertext value of the name and age. And again, if I have to decrypt it, then I can do the same method that we discussed earlier by passing this name, and I will get that actual age of the person. Okay, so this is the way it works. But only thing that we have to take into account is, suppose if you have got a lot of insert statements into the database, then better not to use it, because it will be fired every time and it is going to create a bottleneck for the CPU on the target database. Okay, so this is the something that is what. Any questions till now?
Abhishek, Ravi here. So another question was, so since it's a compliance requirement, right? There's no way that we can avoid this, and there will be encryption and decryption. But definitely the decryption process will have some overheads, right, in terms of performance. And when we are using, let's say, especially the data for analytics, performance is the key, right? So in your specific use case, did you like have to do some optimization over it, or was it just acceptable to the customer in terms of the performance?
Decryption was not done for all the data, right? Because
Okay.
when we are doing analytics, right, only for certain
Mhm.
use cases, right? As I discussed earlier, that if you are going to hospitals and you have to trace the person.
Correct, correct, correct.
So,
Yep, yep.
so
Absolutely. Understood. Understood. But it is specific to the PII data, or let's say the data where compliance comes into picture, right? So just trying to understand, in your specific use case, was there any requirement where the, let's say, the analytics team felt like the performance was not good enough, or was it in the acceptable standards already?
Yeah, actually, we are still in the development phase. So what
Okay.
was required from
Okay.
our is, that initially we have to load the data, and some users who are, having the privileges, they will be able to
Hmm.
decrypt data. So they will be running very less use cases, and that was the main requirement. So we didn't face any performance issue as of now. But maybe
Okay.
since it's done in the phases, so later on we can face this issue, and we have to go for a different engine in the Aurora, and we have to upgrade those system or tune the queries to make it workable, right? So
Fair
that
enough.
challenge we have not faced yet. Thanks for the question, but we have not faced yet. So
Yeah.
Yeah,
Fair enough,
so
Abhishek.
Amit here, I would like to add something on the analytic question which Ravi asked, right? So, like typically when you're doing analytics, you first of all, analytics would be done in your say data warehouse or say in your data lake, and there you are going to maintain your separate zone where you are going to maintain your private or PI data, okay? And that data could be not masked or it could not be encrypted so that you can do your calculations and run your analytic query. But mostly PI will be addresses, or you can say credit card numbers. So a lot of times you will not be running analytics on those details itself, because as part of analytic you will be more interested in knowing how much sales were done, or so how much sales were done in say a particular region. So for that, PI data will not be applicable because that thing can be handled you won't be needing to run analytics on those column.
Yes, Amit, actually kind of
Yeah,
makes sense. Yeah, yeah. There might
yeah,
be very limited amount of data which probably you want to mask or encrypt. So yeah, that kind of makes sense. Yeah.
yeah.
yeah, thanks, Amit. I completely agree. So any other questions before we proceed? Okay, so this is something that we have discussed earlier, right? We can again use a mapping table to store the anonymized value. And this is the data flow that will happen for the PII table. So there will be two jobs running. One job is going to get all those PII columns and update the table with the anonymized value. And the other job is going to just join these PII tables with the mapping table and get the anonymized value to the table which is consumed by the users, right? So here again, we are using the mapping table. You can put it to the different database, different schema, or S3 bucket, depending on the security requirement, right? Because S3 bucket sounds to be better whenever we are trying to use multiple services to fetch the data from the mapping table. Otherwise, if you have only one database and you don't have that stringent security requirement, then you can keep it on the same database. So this is one of the some POC which has been done for the mapping table. We created the table first, then inserted the data, and then this is the job which animation job one will do. So it is going to update your data with the pseudo encrypt. We have used it. So this is one of the functions in the Postgres that can be used to create a unique random number for each input. But again, we have a data constraint here because here we have to pass the input data as an integer, right? So if you have a text or something, so you have to create your own customized function. And again, we can create a view that is going to hide those actual PIA tables and use the anonymized columns by joining these two tables, and then create a table from this view. And finally, if and when required, we can just go and query those mapping table by passing those anonymized value to get the real number. So this is something that implementable, but as you can see here we need to join these two tables to insert the data into the mapping table, and here also we have to join these two tables to insert the data here. So there will be load on the tables while unloading the anonymized value, and then again loading it into the anonymized value that is any of the users is using in the cloud. So this is some constraint. And one of the important constraint I forgot to mention earlier also, that suppose if you have some constraint defined between your PII table and the non-PII table, right? So that is the, I mean, most of the common question that people ask when we are trying to convert the PIE value to the anonymized value. So in that case, actually, you have to just make sure these two different set of tables, they are not dependent on each other. If they are dependent, then you have to just move these tables to the PII tables categories, and there will certainly be some lag between those PII tables and the non-PII tables, right? Half an hour lag. And if you have a constraint, then definitely this will not work. Then you can go for trigger-based approach, and you can write that thing in the trigger to update both those tables together. So that kind of use cases we have not used it, because generally in our customers we don't have any dependencies of the constraint for the PII table to the non-PII. But if you have it, in that case what you can do, you can write a code so that to update those tables together, right? So that your constraint will not fail while loading the data into the target. But again, that loading together will happen only when you create a trigger, not by job, because job execution will take time, and I mean you cannot store both sets of table together, right? So that is, I want to highlight it out. Then finally, there are a lot of scope for improvement. We can again do the large scale testing, because this data was not much of the PII data. We have got only 15 tables identified as a PII, and they have got limited number of rows. So if we need to do larger volume set of data, then we will able to classify the different techniques or use cases as well. And the second is the constraint that I discussed, right? If we have some certain constraint dependencies on the PII and non-PII, then we have to write our own code in order to insert the data into the target tables, and that needs to be worked on. And again, the lambda function usage to mitigate by putting it into the trigger, that is one of the things that can be tested, that we have not done because we don't have that requirement. And finally, if you have integration with the downstream, whether your multiple RDS, Redshift, and S3 different services are accessing those mapping table for some or the other purpose, then you can store the centralized stored like S3, and then you can use this data for the analytics. Okay, so this is what I want to cover it out for today, and let me just give you a short demo as well. So I will just show a demo on the PG crypto extension. Okay, so let me just try to drop one database first. Okay, it is not there, so I will just create it. Now I'm going to create this database. Then let me connect to this database again. So this is I am connecting to the new database which I created. Then I will create this PII schema in this database. And then I will just set the search path. So all these objects which I need to create now will be created in the PII schema. So this extension is, we can install it inside this schema as well, because we are going to use it only for these tables. And then I am going to create this table which will be your PII table, and then inserting some data into it. Then I'm going to create one anonymized table based on this PII table. This will not have any rows. This is only the structure of the table. And then finally, I am going to insert the data. Yeah, so these are the name and the age ciphertext value. This is the name and this is the age. And again, if you want to see the actual value, you can run this script to actually get to know what is the actual value of the encrypted data. Right, so this is quite simple to implement in the POC, but again, in the database, you have to just write all this logic to incorporate in the job and do the proper testing, okay, before completing this. So this is something I want to, share it for today. Any questions, anyone? I mean, this is a very vast topic. We can keep on discussing this again and again, but this is something I want to just focus on the use case which I have done it. And anyone has any questions, please go ahead. So there is a long silence. I will take it as a no. And if something is there, please you can reach me. And there are a lot of documentation available as well, so I can share it. And thanks for attending the session and have a great weekend. And fill the feedback form whenever you will get it, because this will help me to improve my session skills and understand what was lagging in today's session. So thanks a lot for attending the session, and I'm just concluding the session.